Okay, hello dear friends. So here are some problems. Let's do this one. 64. Find the domain algebraically. 用代数的方法. So we need to find the domain. Now let's copy this problem. Function f(x) x 三次方减16x square root of x minus 3. So if we look for domain, we look for what is not allowed in the computation. Under the square root, x minus 3 must be positive, 0 or positive, right? It cannot be a negative number. And here on the bottom, the denominator could not be 0. So we first analysis what is we are looking for. So we can separate to make it a separate problem. First, x minus 3 must be bigger or equal to 0. So x bigger than 3. This is the first part. We make sure, so if we put a number line 0, 1, 2, 3, so you cannot see. Okay, so this is a solid circle. It's a dot, it's not a circle. So anything from here. Now we look at the bottom part. The bottom part, x squared minus 16x cannot be 0. It can be positive, it can be negative, it can be natural, any real number, but it cannot be 0. And for this, we can factor it into, take out an x times x squared minus 16, right? We did not change anything. So x cubed, x 16x, so we did not change anything, cannot be equal to 0. And x squared minus 16, we can still factor it. X times x plus 4 and x minus 4 cannot be equal to 0. So if the three matters time together, none of it could not be 0. So x could not be 0. You can be anything, you cannot be 0. Something else, you cannot be. You can be anything, you cannot be negative 4. You can be anything, you cannot be positive 4. So put on the same dot, we use another color. So x cannot be 0. It's okay, because in the first condition, x must be bigger and equal to 3. So this side, it's not even inside the consideration. And next, x cannot be negative 4. And this is negative 4. X cannot be here. It's okay. It's not even inside our consideration, right? And x cannot be positive 4. Here there is a dot, and we need to cross out this dot. So the final result, the domain is x bigger than 3, but x cannot be 4. X larger or equal to 3, and x not equal to 4. So this is the domain we are looking for this question. Make sense?